Hola friends, welcome back to Simple Haskell. Hope you are enjoying this. Seeing something I do not need here. So today I'm going to be talking about Reader and ReaderT. And there's not a whole lot to say about Reader because Reader is kind of, in my opinion, pointless on its own. I have no idea how to make use of it in a real way. ReaderT, however, does have some uses, and the most common use of ReaderT is for server config. So, and why is that? Well, with server config, when we think about it, we are effectively starting with some value, and we are never changing from that value. We wouldn't want to change the value of config in the normal running of our program. And I don't know, I guess in some edge cases that you might want to do that, I don't know. And in that case, then you don't want ReaderT. But if you want a read-only environment, it's called, or is the kind of term that's talked about with ReaderT all the time, then you want ReaderT. If you want a read-only environment, or environment just being effectively any type, then you want ReaderT. And there's, in terms of the general scope of environment, what's meant by that, I looked up some other cases where you might want to use Reader, and one example that came up was for, what was it? Something to do with stock prices, or you could have a list or a record of what stock prices are available at the moment, and or what the ticker symbols were. I believe, I don't know. I didn't really look too much into that example, but the common case is for config. So you want to run a function which has some config, and now if you're coming from a imperative object-oriented language, you just have global variables which you will use. You might be using for your config. I can't comment on that because I've never personally used a global variable for config, but that's kind of the idea. We want to use this config in a number of different places, and we're too lazy to pass it around all the time. Right? We don't want to have every single function reading as this takes a config and does something. This takes a config and does something. This takes a config and does something. Although that's still kind of what we have to do, because we are working in Haskell, a pure language, which by definition means that we have no such thing as a global variable. Any pure function only has access to the memory that it was passed. Right? So if I give this function a string, then it has access to that string and nothing else. It can make new stuff inside of that function, but it only has access to the string externally. And so I guess that kind of births the idea of why we need something like ReaderT. And so what ReaderT is, said in another way, and yet another way, is a monad which has environment variables, or it has kind of our config sitting in the background. And so this is the type of reader where, and so again, this is not ReaderT but reader. And so all reader is basically a function which takes some R. So in our case of server config, this takes in some server config. Right? We could parameterize this so that ReaderT takes in some server config and it gives us back, and then we built a reader monad. And so without much further ado, I don't see how to talk at a theoretical level much more about this, and that's probably with good reason. So I figured a great example here was where could we make the ReaderT monad actually useful? And so ReaderT would be more like this. And so that might, and so I'm doing this and state and writer as a kind of special highlight series, just because there's a bit of weirdness with them. Like, you know, with maybe T, we had new type maybe T, MA is maybe T, run maybe T, and so we saw that the M applies to or wraps the maybe T. Whereas here, and we'll notice this pattern with other monads which contain a function, right? This being our function here, we will notice that the M applies to the return argument instead of wrapping like this. And why is that? I mean, I don't know how to honestly explain that. I mean, the best way I can think to explain that, and it might not be useful at all, but if you were to fmap over a function, so if we said fmap plus 1 over, well, plus 1. If we fmapped, we can actually do this, and I believe this will type check. So we can see that this is valid. We can fmap, and and we'd always fmap a function which takes a singular argument, a plus 1, and then we can fmap that over the plus 1. And why is that? Well, the reason for that is because if we look at the type of plus 1, well, I mean, it's not too surprising. It's taking a singular argument and returning a value. And so I'm not sure where it would exist, but there is such a thing as a functor instance. Oh, this is perfect. Yes, we can see there is such a thing as a functor on functions. Same with monads. And so I guess maybe a way you can think about it is that this is sort of like the monad of in terms of functions. And so that might be a little bit confusing, and I'm not sure how to simplify that. But this is what ReaderT looks like. And maybe I'll do some research into that and try to do a video which explains that in a deeper manner, but I don't think it's even important to this. Besides knowing that this is a common pattern that we will see for ReaderT, for StateT, for WriterT, and also RWST, which is a combination of the three. But yeah, so where can we actually use this? And again, just to like, let's say this is IO, then this would be IO. So this is saying that this run reader is a function which takes some R, which is going to be our server config in our case, and it's going to return some IOA. And I guess, even a simpler way to think about it is just, that's a lot more useful than if the IO was to wrap the function. Like a function, I can't imagine a case in which a function is the target of our program. Like, we want to return a function. Heck, we can't even print out what a function looks like, so why would we do that? It would make more sense to have a function which is monadic. And so this is kind of monadic for whatever M is. Yeah. So I've actually written a little program here, and so what this is doing is making it easier for me to spam people. I'm just gonna start firing off those awful spam emails. I get 1 billion $500 Walmart gift cards a day, and for some reason I haven't used them yet. So, I sent $3 million to them, but they never sent back the $500 gift card, and I just don't know why. But yeah, so we're gonna be sending out $500 gift cards from Walmart, and actually, well, no, we're gonna be trying to reach people about their car's extended warranty. And so, how are we using Reader here? Let's focus on that. So, I have my Reader Func, and if we look at it, before we actually dive into it, we can see that it reads as the type of my Reader Func is ReaderT config IO unit. So the inner monad is IO. It's the what I'm going to read into my Reader monad is a config, and it's going to end off with some unit. So I'm not going to actually return anything from my Reader Func. However, I just don't see a need for it, because what I'm trying to do is I'm trying to send emails. So there's nothing useful about I'm not going to return the email I sent. I could, but I don't see why I would. And so this function do SMTP port, it just returns this unit, and that's where we end up with a unit. But anyways, we are in the ReaderT config IO monad. So that means that this must be run. In order to run this expression, we have to give it a config. What is a config? Well, let me tell you about it. So I've defined a config, and again, this is just any arbitrary function I can define here, to be something that makes mail. So I only need to give this an email address, and then it will give me mail. And what is mail? I'm not going to get into that, but, well, I'm not even going to get into that. What you need to know is that I can, mail is a type that defines the structure of an email. Again, the tutorial is not on mail, it's on ReaderT. I could do it might be even a worthy tutorial to do in the future, but mail is just some type that defines how an email is formed. And I can use my function send mail to send, mail. And so I have I have a record here of make mail, which is parameterized with an email, with some function, which is able to take an email address, do some stuff in the middle, and give me back a mail. I don't care what it does in the middle, I suppose. And that's up to imagination, I suppose. And then also the config has a host and a port, which I will need in order to send mail on my server. And so nothing about this is something that I want to edit as the program goes on. And I will only want to find what the value of this is for my use in certain expressions or functions, I suppose. And so, yeah. So this is what config is. And this brings us now to our main function, because we are going to try to run my Reader Func. And in order to do that, we're going to use run ReaderT, which we check the type of. Control dot monad dot trans dot reader. I'm also just going to set my prompt quick. We look at the type of run ReaderT. You can see that it takes in ReaderT RMA expression, a corresponding R to that type, and will bring us back a monadic action, where the monad is defined by the ReaderT. And so in this case, we're saying IO, so that it's compatible with this outer shell. IO always being our real outer shell. And yeah. And now I will say too, I kind of made a bit of a, well, not a mistake. I don't make mistakes, ever. I'm just perfect. Yeah, that's a lie, and arguably a mistake in saying that. But I said that we're always going to be running in IO at the end of the day, even if we have a massive transformer stack. And that's not necessarily true. Like, for example, I could do something that says let x equals run reader. Reader just being the non-monad transformer variant of ReaderT. And I say, my reader is some f, which is of the type reader int. It takes an int in and does nothing with it. I'm not actually going to define f here. And then, this takes an int. Boom. Actually, I could define f pretty easily. I'm just going to do this quick, just for the sake of it. So I could say that f is just literally this. It does absolutely nothing. Although I believe... Just going to say that for good measure. Where did I define that? Oh. You know what? I am going to be lazy. And so, anyways, the point is that I could run this purely, and so x would just be this here, if I recall correctly. Yes, I would literally just get back a tuple here, or sorry, a unit or empty tuple. And so it is possible to do it purely, but largely speaking, we are going to run our monad transformer stack like this with run ReaderT, where the outer monad definitely impacts this one. And so these should be the same. Given that I am running ReaderT of my reader func, right, this here dictates that this must be IO because this is IO. Because I'm running my ReaderT function in the context of IO. Yeah. And so, anyways, the core point here is that we have some starting config that we have built here. And so I said that my config uses this make mail function, which is right here. We can see it as is, and all this is going to do is build a message to some given email address that I pass to that function. And so I'm not going to actually call this function yet. I'm going to put it into my config. It will be this field. And I'm going to say my host is mailtrap for testing, and that my port is 2525, as is customary. I believe. I don't know. I'm not an expert on mail. I am just one myself. Dad jokes. Anyways, and so now this is going to actually run this expression with this as a passed-in argument. And so what does that mean for me? Well, I can do any sort of monadic action here without having to think about what's going on with my config. I don't have to continually pass it through, kind of thing. It's just always implicitly there, and this is really because of how I guess how monads work in and how the continuation or monad continuation function, I'm going to call it, works for ReaderT. This is always going to keep on passing. So if we have f and g, f is going to do some stuff, and I guess it won't, in this case, it will not affect the config that we passed in, but F and G, like this will always continually pass our config, even in the case of this, where, if you recall, is defined like so, or well, this is really, so if we have A and B, this is the same as A and B, where we throw out the value. But the thing is, the config is not our value. Config is part of the monad itself. So, you know, I won't get into that with any more detail, just because, I mean, the truth be told, I'm not exactly sure what the monad instance of ReaderT looks like. You could look it up quite easily, but again, I don't think it's valuable for this video. The point is that this ReaderT config will continually get passed through our monadic actions, no matter what. And so, yeah. And so, how do we actually use reader? So I have a function here, asks. And how did I get to asks? So, so this is where it comes from control.monad.trans.reader. And as we can see, reader has actually been rewritten to be written in terms of ReaderT. And I mentioned in the last video how identity is used to kind of simplify a monad transformer. And, you know, it's a very common pattern. I believe there's actually a mathematical name for it, like KCM, something along, I don't know, something along the lines of that. But anyways, what we are using is asks. And so asks is a bit of a, it's not the most simple function in the sense of asks is built in terms of ask. So what is ask? Let's start there. So if I said ask, this would give me the entire env. This would give me, if I was to annotate the type of this, it would be config. So, meaning I could say that my make mail, I'm going to call it make m, is make mail env. And that would give me, this would mean that my make m is then of the type email address to mail. I've just unwrapped it. Asks takes a function that we can use on config. So if you look here, you notice that make mail is, well, this record function here. And so type of asks is taking a function which is going to use this R and give us an A. And then it is going to give an action which returns that A exposed. Right? Very similarly, if I look at ask, it's just going to expose the environment so that I can take use of it, or I can make use of it in my code. But otherwise, it would be very easy, you know, for some reason, if I wanted to do this, to never access config and just go about my business, and it's just always there in the background. And I can ask this at any point. I can even ask this, you know, multiple times. Env copy 2. I'm just effectively getting a copy of the environment, right? Env copy 3. Not sure why this is useful in the case of reader, because, you know, it's just going to be the exact same thing every single time. But so yeah, and we could define asks. So if I wanted to do ask here, let's say I wanted to get the port double prime, I am going to say ask, and then I'm going to do port fmapped. I need to fmap because I'm going to fmap over the ReaderT RM in order to access this R, and then port on this being config. So applying the function port to config is going to get me my port. And that's all there is to it. And now that I have done all of that jazz, I can use these. And so this gives me all of the functions that I need in order to do my business. This is going to quite literally send an email to someone with the email of santa@theclaws.com, heisenberg@bluestuff.com, the man, the myth, the legend @gmail.com. And so I am doing this just because I don't want to, I don't know, I want to make it very easy to send emails to multiple people, and that's how I'm using Reader. And even then, I will say, I'm still not sure why I would need Reader here. Like, I mean, like, you know, my brain is kind of going like, okay, but like if let's say we had config here, you know, we took in config, and instead, or I'm gonna copy this over, and then, yeah, so if we instead had config and then did IO this, I'm not sure why this is worse. And I'm not sure what the downside to this is, in all honesty. I have never truly understood. I mean, like, there are cases, and I think the case for ReaderT comes in when you're dealing with a massive system of many different types, and you know, it becomes a matter of control flow and keeping your code readable, is I think where ReaderT really shines. But otherwise, you know, for a simple function like this, and again, I'm not going to build an entire massive web server. It actually wouldn't be too hard, but I'm not going to build an entire massive web server, you know, for the purpose of this video. I don't think that'd be helpful for learning, is why. Not because I'm lazy. I mean, I am lazy, but, you know. So here, I mean, there's really no reason I can't just do this. And then I don't even need to use this liftIO. And that actually brings me to my next point. So I didn't think it was worth covering in the last video about monad transformers generally, because it's not general to monad transformers. I mean, it kind of is in a way, but liftIO is a specialization of lift for IO in particular, and so in the cases where you might have to think about lift, you know, how many times you should lift for the inner monad, you don't need to do that with liftIO. liftIO, you could have a monad stack of 30, and you would just say liftIO print hello, or halo. I can see your halo. And so yeah, that's what IO or liftIO does. And so I'm going to use it here because this allows me to run just some arbitrary IO action inside of my monad transformer. And so to prove that, if we look at the type of do SMTP port, of course not. What is it? Oh, it must be this. Yeah, and I can see that this is of the type IO. I could also, for the sake of simplicity, do liftIO print hey. I'm walking here. And yeah, that's all there is to say about ReaderT. Thank you so much for watching. I hope you enjoyed. Maybe you find some beautiful use case for ReaderT, and I'm sure there is one. I'm definitely seen it in a lot of code, but I've never personally found a reason myself. But I hope this was definitely helpful for you. And yeah, I'm just looking over to see if I missed anything. No, I did not. So we are good to go, and have a great time. Thanks so much for watching, and cheers. Please like, share, subscribe, all that good stuff.